In the 10 miles between Leicester Park and Stark's Knob, traveling east, we go from one geologic province to another. We go from flat-lying rocks at Leicester Park to the very front of the Appalachian Mountains. These are folded and thrust rocks that were deformed in the Tectonic orogeny 460 million years ago. The time of that deformation is the same age as Stark's Knob. Okay, Stark's Knob is located just a little bit north of Schuylerville, New York. Right in the distance actually is the Hudson River in back of those trees. You take a turn to the west, drive up a couple hundred yards to the entrance to Stark's Knob Quarry. The entrance to Stark's Knob Quarry is marked by a sign, and in the background you will also see in the distance additional signs explaining the site. This is the quarry at Stark's Knob. We've got this vertical wall because the rock was quarried, it was pulled out, and it was used to line the very nearby Champlain Canal. That was beginning in 1900s. Shortly after that, 1916, it was given to the State Museum. Now what we end up seeing here is a massive rock that's 180 meters long, it's 40 meters thick, and it's almost like a hockey puck. And it's like a hockey puck because it was caught at the basal thrust of the tectonic overthrust. Now we're going to take a closer look at these lumpy structures and figure out what those are. And what you're going to see here is precisely what you would see on a trip to Iceland. These are some of the best pillow basalts that you will see in eastern North America. A pillow basalt is formed when you have volcanic rock coming up from depth, and it comes out of the vent, and you make a little bit of a volcanic edifice, a little volcanic mountain, and the lava rolls down the flanks, and they just assume the form of pillows. And if you look in some places, oddly, you see light areas on the pillows that are limestone fragments. We'll see a lot more about those limestone fragments after a bit. Now what we saw at the last locality were pillow basalts. And these are basaltic rocks. They were liquid. They flowed out of a vent of a volcano, rolled down a slope, and came to rest. And they have this pillow shape. Another thing that occurs in underwater basalt extrusion are lava tubes. And you've seen these in films of Iceland. They can be on land, and you'll see people walking through these great big openings that were formed with lava coming out, making a tube. And one thing that often happens is that the lava doesn't completely leave the tube, and at the top of it freezes over. Then the level of the lava falls, and you'll have another frozen layer formed. And in this case, we've got a total of 5 basalt ices that mark levels as the lava retreated probably down this lava tube. Now, they're so distinctive because these lava ledges are covered with a limestone. What's a limestone doing here? There's a lot of limestone central New York in rocks of the same age, but no indication that that limestone is eroded off of eastern New York. Rather, this limestone is formed because you've got hot rock ejected underwater. It heats the water, and calcium carbonate, lime, just simply settles out like a snow. Now that calcium carbonate that's produced when you degas seawater, you get rid of the acidic CO2. The lime settles out. The lime will actually settle on the pillows, and it'll make fine-grained layers of limestone. And here's the actual contact with a pillow. You can see fragments of basalt. There's a planar lamination. Oddly, the top of this is reddish. The top of this is reddish because this limestone lens was baked by an overriding pillow that fell onto it. We were particularly interested in these limestones because they may give fossils to actually date this. No one knew the age of this rock, really. We did find a fossil snail. The fossil snail fits with what we call Trenton Group rocks in New York. This makes it Upper Ordovician. It makes it about 460 million years old, and about 460 million years old is the same time as this major tectonic orogeny. We have a figure of what's happening on the signs below. Now, this geologic timescale puts the two localities, Leicester Park and Stark's Knob, into perspective. The Leicester Park stromatolites were of Cambrian age. The best call is 490 million years ago, and New York is at the tropical edge of a continent. It's a passive margin. When it comes to Stark's Knob, we're significantly younger, probably about 460 million years old. This is when the Stark's Knob pillow basalt is formed, and we have fossil evidence that covers this. This is no longer a tropical passive margin. This is the Ring of Fire in the Ordovician along northeastern North America. It was important that Stark's Knob be preserved and that the rock be available for study. In our work on it, we ended up actually changing plate tectonics theory. We ended up saying that this is the time that the Tectonic Island arc is colliding with North America. That's the Tectonic orogeny about 460 million years ago. It's colliding and overrunning eastern North America. Now, this Stark's Knob is interpreted to be on the North American plate. So what's happening? The Tectonic Island arc is overriding North America. Stark's Knob is formed here. But how is it formed? We have the process of subduction where the edge of ancient North America is going down under the Tectonic Island arc. But how is it going down? Is it being pushed down in some way, or is it being pulled down? Our interpretation is that this edge of eastern North America is relatively cold rock. It is dense rock. It is sinking into the lithosphere. As it sinks, fractures take place, and you get small volcanic edifices like this. Approximately 2 years after we published on Stark's Knob, the Japanese were finding very similar small volcanic edifices that were being subducted down into the Japan Trench, a modern example of this ancient occurrence.